March 7, 1944, 8:30 in the morning, Vice Admiral Ozawa stands on the command bridge of the aircraft carrier Taiho, watching the morning sun climb over Linger Road's anchorage near Sumatra. The massive ship beneath his boots represents something extraordinary. 32 months of continuous labor, 16,000 tons of steel carefully welded and riveted together. And perhaps most importantly, the entire remaining hope of the Imperial Japanese Navy concentrated in one vessel. Taiho is the only purpose-built fleet carrier that Japan has managed to commission since the war started. One single carrier in 32 months of construction. But here's what makes Ozawa's blood run cold. Intelligence reports that arrived just 3 days ago contain numbers that seem impossible. The Americans have commissioned 17 new fleet carriers during that exact same period. 17 carriers while Japan built one. And the terrifying part? American shipyards had stopped bothering to count the smaller carriers they were producing. The mathematics make absolutely no sense to Ozawa. These numbers violate everything he understands about industrial capacity, about shipyard limitations, about construction timelines, and the physical realities of building warships. Japan spent decades, literally decades, building what was considered the finest carrier force anywhere in the world. The Americans supposedly started from almost nothing. Yet somehow, in less time than it took Japan to construct one Taiho, American shipyards were launching brand new carriers every single month like clockwork. Ozawa knows exactly what these numbers mean. They mean Japan has already lost this war. The shooting will continue for another 16 brutal months. Thousands more young men will die in combat. But the ultimate outcome has already been decided by mathematics, by steel production, and by welding torches in distant shipyards 7,000 miles away across the Pacific. The question that keeps this admiral awake every single night is devastatingly simple. How did they do it? Now, before we dive deeper into this absolutely mind-blowing story about industrial warfare and how America built an unstoppable navy, I need you to understand something. If you're fascinated by the untold stories of World War II, if you want to know how seemingly impossible victories were actually achieved, if you love learning about the moments that changed history forever, then hit that subscribe button right now, because we're bringing you the stories that nobody else tells. The real reasons wars were won or lost. The human ingenuity and industrial miracles that shaped our world. Stories packed with facts, drama, and revelations that will change how you see history completely. So subscribe and turn on notifications, because what you're about to discover will blow your mind. This isn't just another war story. This is about how one nation's factories defeated another nation's warriors. And I guarantee by the end, you'll see World War II in a completely different way. Now drop a comment below telling us what you think. Did industrial power really matter more than military courage? We want to hear your thoughts. All right, let's get back to March 1944 and discover how this impossible situation came to be. Japan entered World War II, possessing the most powerful carrier force ever assembled by any nation in human history. 6 fleet carriers, all modern vessels, all battle-tested and proven in combat. 2 additional light carriers. Every ship was ready for action. The American Pacific Fleet, by comparison, had just 4 carriers. Japan enjoyed clear numerical superiority. They had tactical superiority developed through years of training. They had 2 full decades of carrier doctrine development that no other navy could match. The Japanese Navy had been constructing carriers since 1922. They understood carrier operations better than any naval force anywhere in the world. Their pilots were recognized as the best-trained aviators on the planet. Their aircraft designs were proven effective through years of combat experience in China. Their tactics had been refined and perfected through countless hours of practice and real warfare. American carriers, by stark contrast, were largely untested in major combat. American pilots lacked the extensive combat experience of their Japanese counterparts. American carrier doctrine was mostly theoretical, developed in peacetime exercises rather than actual war. On paper, looking at every measurable factor, Japan should have dominated carrier warfare for years into the future. But paper lies, and numbers tell brutal truths. By December 1941, Japanese military planners understood they faced one fundamental problem that overshadowed everything else. The United States possessed an industrial capacity approximately 10 times larger than Japan's entire industrial base. Raw steel production figures were staggering. Shipyard capacity was incomparable. Machine tool manufacturing wasn't even close. Everything favored America by ratios that seemed utterly impossible to overcome through any military strategy. Admiral Isoroku Yamamoto understood this industrial reality better than anyone else in the Japanese high command. He had served as a naval attaché stationed in Washington before the war. He had personally seen American factories operating at full capacity. He had toured American shipyards and witnessed their capabilities firsthand. He had studied American industrial infrastructure in detail. Yamamoto told the Japanese government something they didn't want to hear. Japan could win battles for 6 months, perhaps as long as 1 year if everything went perfectly. After that initial period, American industrial power would inevitably overwhelm anything Japan could possibly produce. The government chose to ignore his warnings completely. They believed that Japanese spirit could overcome mere steel. They believed tactical brilliance would defeat numerical superiority. They believed Japan's warrior culture provided an intangible advantage that factories and assembly lines could never match. They were catastrophically wrong. The first carrier Japan lost in combat was Shoho, sunk on May 7, 1942, during the Battle of the Coral Sea. She went down after absorbing 13 direct bomb hits and 7 devastating torpedo strikes from American carrier aircraft. Shoho was classified as a light carrier, displacing 11,000 tons, originally converted from a submarine tender. She carried 30 aircraft when fully loaded. Her loss was certainly significant, but not immediately catastrophic to Japan's overall naval strength. 1 month later, however, Japan suffered a blow from which they would never truly recover. At the Battle of Midway, Japan lost 4 fleet carriers in a single devastating day. Akagi, Kaga, Soryu, Hairyu, all gone. All sunk by American dive bombers during a battle that lasted approximately 6 minutes of actual combat. Those 4 carriers represented 20 years of Japanese naval development and investment, 40,000 tons of irreplaceable combat power, 250 aircraft and their highly trained crews, all destroyed in less time than it takes to eat breakfast. The Japanese naval staff back in Tokyo received these catastrophic reports and immediately began calculating replacement timelines. The mathematics were brutal. Akagi had taken 4 years to construct from keel laying to commissioning. Kaga had required 6 years of construction time. Soryu took 3 years to build. Hiryu required 4 years. The average construction time worked out to 4¼ years per fleet carrier. 4 ships had been lost. Replacing them would theoretically require 17 years of total construction time. Japan operated 3 major shipyards capable of building fleet carriers: Yokosuka Naval Arsenal, Kure Naval Arsenal, and Kawasaki Shipyard located in Kobe. All 3 facilities were already working at absolute maximum capacity. They were simultaneously building destroyers, cruisers, submarines, and merchant vessels desperately needed to replace combat losses and support ongoing offensive operations. To replace those 4 lost carriers would require dedicating all 3 shipyards exclusively to carrier construction for nearly 6 years straight. That meant no destroyers built during that period, no cruisers, no submarines, no merchant ships. Japan simply could not afford that kind of specialized focus. The war required everything simultaneously. The naval staff made a calculated decision. They would complete construction of 1 new fleet carrier called Taiho, which had already been laid down before Pearl Harbor was even attacked. They would convert available merchant ships and seaplane tenders into light carriers as stopgap measures. They would design an entirely new class of smaller, cheaper, faster-to-build carriers. The plan appeared reasonable when written on paper. Taiho would provide genuine fleet carrier capability. The conversions would supply interim replacements to maintain some carrier strength. The new Unryu-class carriers would eventually restore Japan's numerical advantage in carrier forces. It was a logical plan, carefully calculated with available resources properly allocated. The plan failed absolutely and completely. Taiho's keel had been laid down on July 10, 1941. The ship was finally launched on April 7, 1943. She was commissioned for active service on March 7, 1944. 32 months total from keel laying to commissioning. That timeline was actually impressively fast for Japanese fleet carrier construction. Shokaku and Zuikaku, both laid down in late 1937, had required 44 months and 45 months respectively to complete. Japan had genuinely improved its carrier construction processes significantly. 32 months represented an achievement worth acknowledging. But then the Americans showed what was actually possible. The Americans commissioned USS Essex on December 31, 1942. Her keel had been laid down on April 28, 1941. 20 months total construction time. Essex was actually larger than Taiho in most measurements. She displaced 27,100 tons standard compared to Taiho's 29,300 tons. She could operate 90 aircraft compared to Taiho's capacity of 75 aircraft. 20 months from start to finish. The Americans had constructed a larger, more capable carrier in 37% less time than Japan's fastest construction program ever achieved. But that stunning achievement wasn't even the truly shocking part. The genuinely shocking part was that Essex was merely the first of many. In January 1943, Lexington was commissioned. Then came Yorktown. Then Bunker Hill. Then Intrepid. Then Hornet. Then Franklin. By December 1943, the Americans had commissioned 11 Essex-class carriers. 11 complete fleet carriers in just one calendar year. During that same year, Japan commissioned exactly one carrier, Taiho, just one. In 1944, Japanese naval staff studied intelligence reports flowing in from multiple sources. They checked the numbers repeatedly, convinced there must be errors in translation or interpretation. They initially assumed American propaganda was deliberately inflating production figures to damage Japanese morale, but reconnaissance aircraft confirmed the reports independently. Photographic intelligence from multiple sources confirmed the same impossible numbers. Intercepted radio traffic confirmed identical data. The Americans genuinely were launching new carriers faster than Japan could train enough pilots to fly aircraft from them. The question that haunted every Japanese naval planner was devastatingly simple. How? The answer begins with a man named Henry Kaiser. Kaiser had never built a single ship in his entire life before 1941. He wasn't a naval architect. He wasn't a shipyard owner. He was a construction engineer who specialized in massive civil engineering projects. He had built dams across America, roads connecting distant cities, bridges spanning impossible gaps, the Hoover Dam, the Bonneville Dam, the Grand Coulee Dam. These were massive concrete structures that required moving literal mountains of material and coordinating thousands of workers simultaneously. In 1941, the United States Maritime Commission faced a crisis. They desperately needed cargo ships, not dozens of cargo ships, not hundreds. They needed thousands of cargo ships to transport food, fuel, ammunition, tanks, aircraft, and troops across both the Atlantic and Pacific Oceans. Traditional shipyards estimated it would take approximately 6 months to construct a single cargo ship. That was considered normal industry standard. That was simply how shipbuilding had always worked throughout history. You laid down a keel at the bottom, built upward methodically, riveted steel plates together piece by piece, installed engines and machinery, launched the completed hull, then spent several additional months finishing all the interior systems and fittings, 6 months minimum per ship. The Maritime Commission needed 2,000 ships built as quickly as possible. Using traditional methods, that would consume 1,000 years of total shipyard capacity. Kaiser examined the problem from a completely different perspective. He didn't see ships the way traditional shipbuilders did. He saw steel structures that could be broken down into standardized components, prefabricated in separate specialized facilities, then rapidly assembled at the shipyard like giant construction projects. Instead of building ships slowly from the bottom upward one piece at a time, Kaiser proposed constructing ships from large sections welded together. Traditional shipbuilders declared this approach was absolutely impossible. Riveting was proven reliable technology used successfully for decades. Welding was considered risky and dangerous. Welded seams could potentially fail under stress. Cracks could propagate through welded joints and literally break a ship in half during rough seas. Kaiser calmly said he would accept the risk and make it work. He constructed 4 major shipyards in Richmond, California, located on San Francisco Bay. He recruited workers from all across the country, many traveling from states that had never seen ocean-going vessels. Most of his workers had never been inside a shipyard before their first day of employment. Many were women entering industrial work for the first time in their lives. Many were African Americans who had been systematically excluded from shipyard employment throughout history. Kaiser didn't care about traditional experience or credentials. He cared about organization, systems, and efficient processes. He divided ship construction into standardized modules. Each module was built in a separate dedicated prefabrication facility. Deck sections constructed in one building, bulkheads in another, engine rooms assembled separately, superstructures built in specialized shops. Everything broken down into manageable pieces that could be constructed by workers who only needed training on that one specific component. The modules were built in whatever physical orientation made welding easiest and most efficient. On their sides, upside down, whatever position allowed welders to work comfortably and quickly. Completed modules were transported to the shipway using massive cranes, carefully lowered into precise positions, then permanently welded together. The first Liberty ship Kaiser's operation built required 196 days from start to finish. The 10th ship took just 45 days. By 1943, Kaiser's yards were completing finished Liberty ships in an average of 42 days. The record that demonstrated what was theoretically possible was 4 days, 15 hours, and 29 minutes. The SS Robert E. Peary, constructed in November 1942 as a publicity demonstration to show America and the world what could be achieved. 4 days to build an entire ocean-going cargo ship. Traditional shipbuilders had confidently stated 6 months was the minimum possible. The technique worked brilliantly for cargo ships. The question everyone asked was whether it could possibly work for carriers. Kaiser proposed adapting his revolutionary methods to escort carrier production. These would be small carriers built on merchant ship hulls, designed specifically for convoy protection duties and ground support operations rather than major fleet actions. The Navy leadership was deeply skeptical. Carriers were extraordinarily complex vessels. They required specialized equipment, highly trained workers, years of accumulated expertise. Kaiser said give him one chance to prove the concept. His Vancouver, Washington shipyard laid the keel for escort carrier Casablanca on November 3, 1942. The ship was launched on April 5, 1943. She was commissioned for active service on July 8, 1943. 8 months total from keel laying to commissioning. The Navy wanted 50 escort carriers built as rapidly as possible. Kaiser delivered 50 complete carriers in just 14 months of continuous production. One finished carrier rolling out every 8 days on average. The Japanese naval staff in Tokyo received these intelligence reports and assumed they had to be translation errors or deliberate misinformation. One carrier completed every 8 days was physically impossible. It violated every known principle of naval construction developed over centuries. But the reports kept flowing in from every intelligence source. Combat encounters confirmed them. By late 1943, American carrier task forces were appearing in Pacific combat zones with numbers that made no tactical or strategic sense. 12 carriers operating together, 15 carriers in one task force, 18 carriers conducting coordinated operations. Japan's entire remaining carrier strength totaled 6 operational ships. The Americans were routinely deploying individual task forces larger than Japan's entire carrier fleet. Where were all these ships actually coming from? Not just Kaiser's escort carriers either. The Essex-class fleet carriers were arriving in squadron strength like waves crashing on a beach. The secret was identical. The same prefabrication techniques Kaiser pioneered for cargo ships, now applied systematically to fleet carrier construction. Newport News. Shipbuilding in Virginia had been constructing carriers since the 1930s. They understood carrier construction intimately from decades of experience. They knew building carriers took years, but they learned from Kaiser's revolutionary cargo ship methods and adapted them. They began prefabricating carrier components in specialized shops. Hull sections built separately, hangar decks assembled in dedicated facilities, flight decks constructed in modular pieces, island superstructures built complete before installation. Everything manufactured in separate locations, then transported to the shipway for rapid final assembly. They replaced traditional riveting with welding wherever physically possible. Welding was dramatically faster, required less skilled labor, created lighter, more efficient structures. They ruthlessly standardized designs. Every single Essex-class carrier used identical plans, identical components. identical equipment throughout. Workers learned to build one specific module perfectly, then built dozens of identical modules using the same techniques. They streamlined construction sequences systematically. Instead of waiting for one section to be completely finished before starting the next sequential step, multiple sections were built simultaneously in different physical locations, then brought together for assembly. USS Franklin, built at Newport News, was laid down on December 7, 1942. Launched on October 14, 1943. Commissioned for active service on January 31, 1944. 13 months total from keel laying to commissioning. That wasn't even the speed record. Several Essex-class carriers were completed in 14 to 16 months. The average construction time was approximately 18 months. Japan's Taiho required 32 months. American shipyards were building fleet carriers twice as fast as Japanese shipyards could manage, and they were simultaneously building more than twice as many. By the time Taiho was finally commissioned in March 1944, the Americans had 17 Essex-class carriers, either in active service or under construction. 17-to-1 ratio. The disparity was even worse when light carriers and escort carriers were included in calculations. America was operating more than 100 carriers of all types combined by mid-1944. Japan had exactly 9 operational carriers total. The Japanese Navy attempted to adapt to this crushing reality. They ordered 14 Untold-class carriers designed specifically for faster mass production. These were smaller than Taiho, significantly simpler to construct, designed around proven technology and standardized components. The Untold class was based on the pre-war Hiryu design, modernized somewhat but fundamentally using reliable proven systems. They displaced 17,150 tons. Could operate 65 aircraft when fully loaded, could make 34 knots maximum speed. They were supposed to be Japan's answer to the Essex-class. 3 were actually completed before war's end. Untold commissioned on August 6, 1944. Amagi on August 10th. Katsuragi on October 15th. 3 carriers commissioned within just 10 weeks. It seemed like genuine progress. Japan was finally accelerating carrier production. Except the Americans commissioned 9 Essex-class carriers during that exact same 10-week period. The Japanese couldn't catch up no matter how hard they tried. Every time they managed to accelerate production, the Americans accelerated even faster. Worse still, Japan was rapidly running out of critical resources. Building any carrier requires steel. Tremendous amounts of steel. An Essex-class carrier contained approximately 27,000 tons of steel plate, structural steel, and armor plate. The United States produced 60 million tons of steel in 1943, 80 million tons in 1944. Japan's total steel production was 8 million tons in 1943, 6 million tons in 1944. The American steel industry alone was producing 10 times more steel annually than Japan's entire industrial capacity. That steel production gap cascaded through every single aspect of naval construction. American shipyards had abundant steel available. They could build hulls, install armor, manufacture machinery, everything they needed. If a section was damaged during construction or built incorrectly, they simply scrapped it and fabricated a new replacement. Japanese shipyards desperately rationed every ton of steel. Every single plate was precious beyond measure. Mistakes had to be painstakingly repaired rather than replaced. Construction continuously slowed because workers spent valuable time fixing errors instead of moving forward with new work. American shipyards had modern machine tools. Thousands of lathes, drill presses, milling machines, all modern equipment, all electrically powered, all capable of precision work at high speed. Japanese shipyards rationed machine tools. Many were old, worn out from overuse, constantly breaking down. Replacement parts were impossibly scarce. Production repeatedly slowed because machinery failed and workers simply waited for repairs. American shipyards had abundant welding equipment. Thousands of welding stations, oxygen acetylene torches, electric arc welders, all standardized, all properly maintained. Japanese shipyards rationed welding equipment too. Many yards still relied heavily on traditional riveting simply because they lacked sufficient welding capacity. The gap extended directly to trained workers. American shipyards employed 2 million workers by 1943. Many were completely new to shipbuilding, but they were trained rapidly using standardized methods and simple repetitive tasks anyone could learn. Kaiser's Richmond shipyards alone employed 90,000 workers at peak production. That was more workers than all three of Japan's major naval shipyards combined employed. The Richmond workforce looked nothing like traditional shipyard crews throughout history. 40% were women. Many had never held any industrial job before the war. They were farm wives from Midwest states, teachers from small rural towns, office workers from cities across America. They learned welding techniques in just 2 weeks of training. They learned crane operation in 3 days. They learned to read blueprints in 1 week. Traditional shipbuilders insisted confidently that these inexperienced workers couldn't possibly build quality ships. They lacked the years of specialized experience required for precision metalwork. But Kaiser's prefabrication system didn't require years of experience. It required workers who could perform one specific task repeatedly and accurately. A welder working in the Richmond yards didn't need to understand complex ship architecture. She needed to know how to weld one specific type of seam on one specific type of joint. The blueprints showed her exactly where. Jigs and fixtures held everything in perfect position. She moved methodically from one piece to the next, welding identical joints dozens of times per shift. Repetition created expertise remarkably fast. After 1 month, workers became genuinely fast. After 2 months, they became impressively precise. After 3 months, they could work faster than traditional shipwrights who had spent years learning their trades. The Japanese simply couldn't replicate this model. Japanese shipyards employed 300,000 workers total. Many were genuinely skilled craftsmen, but they were spread impossibly thin across dozens of simultaneous projects. Training new workers was agonizingly slow because experienced workers were too busy to teach properly. More critically, Japanese industrial culture emphasized traditional craftsmanship over modern standardization. A skilled Japanese shipfitter took enormous pride in custom fitting each individual piece, making countless minor adjustments to ensure absolutely perfect alignment. That traditional approach produced beautiful ships, but it was devastatingly slow. American workers never custom-fitted anything. Parts were manufactured to precise specifications in prefabrication shops. They either fit together properly, or they didn't. If a part didn't fit correctly, it was immediately rejected, and a new one was quickly manufactured. That approach produced functional ships incredibly fast. The philosophical difference reflected the fundamental difference in industrial capacity. Japan had severely limited steel, limited machine tools, limited workers. Every single piece had to be carefully used. Waste was completely unacceptable. Custom fitting ensured nothing was ever wasted. America had abundant steel, abundant machine tools, abundant workers. If a piece was manufactured wrong, they just made another one immediately. Speed mattered infinitely more than achieving perfection. By June 1944, Japan committed 9 carriers to the Battle of the Philippine Sea, 3 fleet carriers, 6 light carriers. Those 9 carriers embarked 450 aircraft total. That was less than half the aircraft capacity those carriers were actually designed to hold. Japan simply didn't have enough aircraft to fully equip its remaining carriers. Worse, the pilots flying those aircraft were tragically inadequately trained. Before the war started, Japanese carrier pilots trained intensively for 2 full years before their first combat deployment. By June 1944, pilots were being deployed to carriers after just 6 months of abbreviated training. They could take off and land. They could fly basic formations. They could operate their aircraft systems. But they desperately lacked combat experience to survive against veteran American pilots flying superior aircraft. American Task Force 58, commanded by Admiral Mark Mitcher, fielded 15 carriers, 7 Essex-class fleet carriers, 8 light carriers. Those carriers embarked 956 aircraft, more than twice the Japanese total. And those American aircraft were dramatically superior to their Japanese counterparts. The F-6F Hellcat fighter had maximum speed of 380 miles per hour compared to the A-6M-Zero's 340. The Hellcat could dive at 450 miles per hour without structural failure. The Zero's maximum dive speed was 360. The Hellcat was heavily armored. Pilot armor, self-sealing fuel tanks, armored engine cowling. It could absorb tremendous battle damage and continue flying. The Zero had no armor whatsoever. A single burst of machine gun fire through the fuel tank would ignite it catastrophically. On June 19th, Japan launched its first strike wave at 7:30 in the morning. 69 aircraft. American radar detected them at 150 miles distance. Fighter directors vectored 40 Hellcats to intercept. The Hellcats hit the Japanese formation 40 miles from the carriers. They shot down 42 aircraft in the first 10 minutes of combat. The surviving Japanese aircraft continued desperately toward the carriers. They encountered a second wave of American fighters, then a third wave, then withering anti-aircraft fire from screening destroyers and cruisers. 8 aircraft broke through to the carriers. They scored no hits. 4 aircraft returned to their carriers. Japan's first strike lost 94% of its aircraft. The second strike launched at 8:56. 109 aircraft met the exact same layered defense. American fighters destroyed 97 before they reached attack range. The third strike achieved one single bomb hit on battleship South Dakota, causing minor damage. The fourth strike became disoriented. Some aircraft found American carriers but were driven off. Others never located the enemy and returned with bombs still attached. Of 450 aircraft launched, 300 were shot down. Another 50 crashed attempting night landings. Japan lost 350 aircraft and their pilots in one day. America lost 29 aircraft. That 12-to-1 exchange ratio reflected cumulative advantages of superior aircraft, superior pilots, superior doctrine, and superior radar direction. Japan lost 3 carriers in that battle. Taiho survived just 3 months after commissioning. She was hit by 1 torpedo from submarine Kavala on June 19th. The damage should have been manageable, but a young damage control officer made a critical error. He ordered the ventilation system turned on to clear gasoline fumes. The ventilation spread fumes throughout the ship. 6 hours after the torpedo hit, a spark ignited the vapor. The explosion tore the ship apart. She sank in minutes. 32 months to build. 3 months in service, gone. By November 1944, Japan had no operational fleet carriers remaining. America had 28. The war ended on August 15, 1945. Japan had commissioned 6 carriers during the entire war. America had commissioned 110 carriers of all types. The ratio was roughly 20 American carriers for every Japanese carrier built. That ratio tells everything about how industrial capacity determined the Pacific War's outcome. If this story opened your eyes to how wars are really won, if you're amazed by these hidden truths of history, then I need you to do something right now. Subscribe to this channel because we're bringing you more untold stories that changed everything. Hit that like button if this video taught you something new. Share it with anyone who loves real history. Tell me in the comments what shocked you most. Was it the construction speed? The worker training? The sheer numbers? I genuinely want to know. These stories matter. These lessons echo through time. And you being here means you understand why. Thank you for watching until the end. I'll see you in the next story, and trust me, what's coming next is just as incredible.